So the key thing whenever we're adding and subtracting rational expressions, that's just, rational expression is just another way of saying fractions containing variables. Whenever you add or subtract, you must have a common denominator. And so we're going to work on trying to find those common denominators, and you've got to be careful when you do this. So the first about 5 or 6 pieces to this will just be kind of directions and how to find that common denominator and what you need to do, and then we'll work through some examples. So the first thing is whenever you add or subtract fractions, you must have a common denominator, as I just mentioned. Unlike multiplying, dividing, like we did on Friday, where we could just do that. You didn't need a common denominator. In these problems, you have to have it. And I mentioned this thing about loners and groups in the video. A monomial, when I'm talking about a loner, we're talking about monomials. There's no addition, subtraction, it's one term. You're going to find a common denominator with monomials one way. Let's say with, not work. Let's fix that. Okay. And you're going to do that a little differently than you do them with groups, polynomials with 2 or more terms. So also the best way to do this is to make sure your denominators are completely factored first. That's going to be easier to find the factors that are in common and what you need to have all together. So for monomials, for loners, for the coefficients, you find the smallest number that all the denominators go into. So we're just talking about finding a common denominator of a regular number. You guys know how to do that. Okay, bless you. Okay, smallest number that all the denominators go into. It could be one of the numbers, the bigger number, okay? But it may be a number that's not already there. Then for the variable part, you're just going to use the higher power on the variable for the variable part. So this is different than greatest common factor. Greatest common factor, we took the smallest power. For least common denominator, we take the highest power. Now, once you find that common denominator, you have to multiply each numerator and denominator by whatever is sort of missing, and you'll see what I mean by that here in a second, from the current denominator to get the common denominator. So what we're going to do is we're going to take those current denominators and sort of build them up to what the common denominator needs to be. And then we're going to multiply the top by whatever you had to multiply the bottom by. Okay, so conceptually speaking, in terms of finding common denominators, it's no different than what you already know how to do. It's just going to happen with factors and groups instead of just numbers. Okay. And then, of course, once you have the common denominator and you've completed your multiplications that need to happen, then you can add or subtract the numerators. So once you've done all the work, the legwork, now you can take care of the tops. But you can't do that until you've done all the legwork. So we're going to look at 3 different examples here in a sec. First example. Okay, so we're going to start off with some denominators that are just loners. They're just monomials. Okay, 3 over 10x squared plus 7 over 15x. Okay, let's talk about the 10 and the 15. 10 does not go into 15 evenly. What number, the smallest number, that 10 and 15 both go into? 30. Okay, so what I'm going to do is I'm going to create one denominator. Okay, and it's going to be 30. Now, that takes care of the number part. What about the variable part between x squared and x? X squared. So I have to take the highest power. So that becomes x squared. Now, here's the part where I was talking about what's missing. Okay, what do I need to multiply 10 by to make it turn into 30? 3. So what's missing is a factor of 3. Okay, let me undo that because I'm going to make some space for the variable. Okay, what is missing from x squared to get me to x squared? Nothing. So I'm actually good there. Okay, So what I'm going to do is multiply top and bottom by 3. Because that's what's missing. To make that denominator turn into 30x squared. So from that part, the top gives me 3 times 3, which is just 9. Okay, now let's look at the second one. What's missing from 15 to get it to turn into 30? 2, and then I'm missing an x to get it to x squared. So overall, I'm missing a 2x. Okay. Now, if I found the smallest possible common denominator, I shouldn't be able to reduce any of this. Okay? If you found, let's say for some reason you said it was 60 instead of 30, okay? Which fine, that's going to happen. That's a common denominator. It's just not the least common denominator. What you would find is that you'd still have a factor of 2 in common, and you'd have to reduce it. In this case, I don't have that, so we're good to go. Okay? Questions on that? Let's look at another one. And x cannot equal 0. Okay? Actually, why don't you go ahead and try and do this one? That was it for that one, yep. Try this one. Common denominator is going to be, between the 16 and the 5 is going to be 80. I'm going to slide this over. Okay, what about the variables? A to the third, B to the second. Highest power in the variable. Now, let's say, for example, that one of them didn't have one of the variables in it, like 16b squared, right? You still have to contain all of the denominators together at some level. So even though this doesn't have an a to the third in it, this one does. So it better have representation in the common denominator. And that's the biggest thing to kind of understand when it comes to variables. All the people in the party got to be included. You can't just shut one door of the party and they can't come in. Everybody has to be included in this group. So 16 is within 80. 5 is within 80. B squared is obviously within B squared. This B is contained within B squared. A to the third is contained. Everybody's in the party here. If you left any part of that factor out, then you're not being inclusive. You need to be inclusive. That's really what this is all about. So we're going to multiply top and bottom by 5 a to the third. All right, because I've already got the b squared. So what's missing? The 5 is missing, and the a to the third is missing. So I've got 15 a to the fifth. Over here, what's missing? I'm missing the 16, and I'm missing 1b. That says 16b, I swear. Okay. That's better. So up here now I've got minus 128bx. That's it. Okay. How many had that right? Good. How many know what you did wrong? How many have a question? Yeah.
On the test, we make like a dumb mistake, and it's just if we put XB instead of BX, will you take off points?
No, I won't. But as a general rule, when you're setting your variables up, we put them in alphabetical order.
Yeah.
Just as a general rule. No, I wouldn't take points off for if you put. Now, that being said, on your test, it's going to mostly be multiple choice. So you have to know how to navigate between BX and XB and recognize that. Okay, other questions? Got one more, it's a little tougher. Okay, this one's, so these two examples involve denominators that are loners. Okay, monomial, monomial, monomial. Okay, this example, A and B could not equal 0. And so those are the couple to look at now is going to contain a little of both. So, first move, you want to factor you want to factor everything. Because sometimes you'll be able to cancel tops and bottoms and it'll make your numbers smaller. But factor everywhere that you can factor first, and then we'll talk about what we need to do next. So, how do I factor the denominator here?
X plus 3, minus 3 times x plus 2.
X minus 3, x plus 2. And then, how do I factor this one? Greatest common factor is 5, x plus 2. Okay, so now I'm dealing with loners and groups, okay? I've got group, loner, group, okay? And again, think of it this way. Everybody it's like they're in one wing of the house, they're in another wing of the house, we need to bring them all together, okay? So there's gotta be an x minus 3, okay? Even though there's an x plus 2 here and an x plus 2 there, at most there is only one x plus 2. So I only need to have one. Okay? Because if I have an x plus 2 in my common denominator, it covers this and it covers that. And then of course I have this loner 5 that we want to not leave out. So my common denominator, here's what it's going to look like. It's going to be 5, it's going to have an x minus 3, it's going to have an x plus 2. Everybody's covered now.
Does it matter if it's like x plus 2 and x minus 3?
Nope, doesn't matter. Just so long as there's an x minus 3 and an x plus 2 in there, the order of it doesn't matter. As far as the loner goes, we always like to put it out front. Okay? So again, that covers this, that covers this. What's missing from over here that this has? It's missing the 5. So I need to multiply the top and bottom by 5. Now up here that means you're going to have to distribute. What is missing from the second fraction?
X minus 3.
X minus 3. Now, here's where you're going to have to be careful. Because in reality, what you want to do is connect this minus and that 4 together. Make it minus 4. Make it negative 4 and distribute it. Okay? So on top, on the first part, I get 5x minus 5. The second part, I get negative 4x plus 12. Okay, again, when I connect this minus with the 4, this is negative 4x. Negative times a negative is positive. Now I'm going to combine some like terms, and then I'll be done.
You're subtracting the 2, so when you combined it...
By making it a negative 4, keep in mind, here's why I can do that, right? The difference between subtracting 4 and adding a negative 4 is nothing.
Right.
And so that's really what I'm doing. And instead of writing plus negative 4, I just made it a minus 4, and now, so I've blurred the lines between subtraction and negatives. And that's totally fine. Alright, so like terms on top, I've got 5x minus 4x, that's x, minus 5 plus 12 plus 7. Then I'm going to squeeze all this in here. Okay?
That's the answer.
That's it. Dunzo final. Now, sometimes... Oh, there's actually one other thing we need to talk about. I really forgot about. Sometimes this may turn into something that you can cancel. The thing that I forgot to talk about in all of these problems were restricted values. Okay. In this problem, so in x cannot be equal to negative 2 or 3.
Oh,
So we have to write that on our answer too?
Yep. You just look out for that. Now, I think the directions in the homework will tell you whether or not you need to write that. But just understand that that's something you got to be aware of. If one of these happened to be x plus 7 and you'd cancel them, you'd still have to have that restriction because the restriction is based off the original problem. Okay.
But that's just for those kind of problems? What about-
Anytime there's a variable in a denominator. So on the other ones, restrictions that we need to watch out for. Again, pay attention to those directions in our homework. I think that'll clear that up a little bit. The restrictions are all based on the original problem. So even when things cancel top and bottom, there still is that restriction because at the very beginning of the problem, you have a situation where a denominator equals 0 if you throw one of those restrictions out after you simplify. You wanna do it, you wanna create your restrictions in the least simplified form possible. Okay, and factored form is not considered least simplified, so, or is considered least simplified, because we haven't really done anything other than rearrange how it looks.